Hello, my name is Neil and I am a Professor of Planetary Science at the University of Oxford. But more importantly, this afternoon, I'm also a member of the Living on the Moon team, and we exhibited at the Royal Society last summer in 2019. Now obviously this year things are a little bit different, but that gives us a chance to answer some more of your questions that are related to the moon and space exploration, which is great. So we've got a great question here from Oscar in Bristol. And Oscar asks, why does water float in space? Now that's a really interesting question, because if I was on the moon, water wouldn't be floating. If you think about it, if you've seen pictures of the astronauts on the lunar surface, they were bouncing around. Now they were sort of walking in a funny way. That's partly because they got these big bulky spacesuits on, but it's also because the gravity, the force that pulls us to the centre of the Earth, towards the centre of the Earth, and keeps us on the surface of the Earth, also works on the moon, because it's connected to the amount of stuff there is in a planet, the so-called the mass. So on the moon's smaller than the Earth, and so what that means is that it actually has less mass, so there's less gravity. So that means on the moon, you actually have a sixth less weight. The force you push down is a sixth of what it would be on the Earth. So that's why they were able to sort of hop and jump around. In fact, one of the Apollo astronauts actually even took a golf club and a golf ball and hit it on the moon, and it went for miles and miles and miles of the distance, or kilometres and kilometres and kilometres off into the distance, because the gravity is much lower and there's no air resistance. Now, interestingly, when the astronauts were going from the Earth to the moon, that's when they were in what we call microgravity. So they were still affected by gravity of the moon and the Earth, but they were essentially falling either around the Earth and just constantly missing the surface by being in orbit, or falling towards the moon if they were going to the moon, or falling towards the Earth. And it's a bit like when you're in a lift or an elevator and it changes, you feel slightly heavier or slightly lighter. Well, that's because the force of the elevator or the lift going up or down is changing the amount of force on you compared to when you're just standing still. And the same thing happens. So when you're in microgravity, you're in what's called free fall. And that means that you essentially float around as if you don't have any mass, any weight. You still have mass, but you don't appear to have any weight. And so what happens is the water then, if you say release a droplet of water, if you're in free fall and you're floating around in space, what happens is it pulls itself into a shape which is the smallest possible surface area, and that happens to be a sphere. So that's why they look like little spheres, little balls. And that's kind of interesting because it just sort of floats around you. So if you think about it, that could be quite difficult if you're in a spaceship or a space station, because you want to be careful that it doesn't get anywhere tricky. Of course, it also means you can sort of suck it into shapes and blow it out and things like that, which is all sorts of fun things. And there are lots of videos online if you have access to the internet that you can see of astronauts doing this kind of thing. It's great fun. But when you're on the moon, you have gravity again because you've been basically pulled onto the lunar surface. It's just that there's a sixth of the gravity that we see on Earth. But it's a great question. Thanks for asking.